Welcome dear students. In this lecture, I will teach you about exact differential equation. Prior to that, let us know what do we mean by Pfaffian differential equation. So a Pfaffian differential equation or differential form is an expression of the form like summation I equal to 1 to n fi. There are n variables d of xi. What does it mean? It means that you have, suppose for I equal to 1, you have one function and you have the differential with respect to the first variable, plus you have the second function and differential with respect to the second variable. Then like this up to you have the nth order function and differential with respect to xn. Okay, that means the nth variable. Okay, so here fi are function of sum or all of the variables x1 to xn. Okay, sum functions of x1 to xn. Okay, and so this is in form. This is called Pfaffian differential form, and equation means there should be equal to 0. Okay, and this equation is called Pfaffian differential equation. Okay, now this is for more general case for n variables. Now let us do for two variables first. That means f1 x1 x2 d of x1 plus f1 f2 x1 x2 d of x2. Okay, so this f1 and f2 now I am writing with m xy dx plus n xy dy, or for three variables p xyz dx plus q xyz dy plus r xyz dz equal to 0. Okay, so these are the examples of Pfaffian equations in two and three variables. Okay, so here in ordinary differential equation or partial differential equation, many a times we will come across these equations. So just remember that these are called Pfaffian differential equation. Okay, where there is a function. Okay, suppose a function m of two variables xy, then its derivative with respect differential with respect to the first variable dx plus nxy with respect to the second variable dy and equal to 0. Okay, now consider a Pfaffian differential equation of two variables, and let us check what do you mean by exact differential equation. Okay, so for a Pfaffian differential equation of two variables of the form mxy dx plus nxy dy equal to 0, that differential equation will called exact when there exists a function f of xy of x and y such that we can write the right hand side as a differential of some function f of xy, as a differential of some function f of xy. That means if we can write the right hand side, okay, equal to d of any function that is equal to m dx plus n dy, then we can say that that our differential equation is exact. What do you mean by d of f of xy? Del f del x into dx plus del f del y dy. Okay, now consider this differential equation y square dx plus twice xy dy equal to 0. Now this differential equation is an exact differential equation or not, how we can check? Okay, so you can see if we take if we take xy square and if we take the differential, what we get? So this is d of any function of two variables. So the by this property, what we can write, del x of xy square dx plus del y of xy square dy. Okay, now this is the partial differential equation with respect to x. What we get? Y square. So y square dx plus twice xy dy. Okay, and we are writing d of xy square. Okay, so that means this equation can be written as d of xy square. So that is why it is an exact differential equation. Okay, so this is our question is this equal to 0. So now what we get, d of xy square equal to 0. So on integrating both sides, what we get, xy square equal to c. So c is an arbitrary constant. So the general solution of this differential equation is xy square equal to c, right? Okay. Now, in practice, it is very difficult to calculate f of xy, so that d of f of xy equal to m dx plus n dy. So, how we can find it? So, there are some methods by which we can find this f of xy. Okay, and we will discuss these methods one by one. Okay, so the exact differential equation have the following important property, is that an exact differential equation can always be derived from its general solution. You can see this is the general solution. So and if we directly differentiate, okay, so its differentiate means what? Del del x of f del del x of this dx plus del del y of this into dy. Okay, differential means d of xy square means this portion. Okay, you directly get the differential equation. Okay, so an exact differential equation can always be derived from its general solution directly by differentiating without any subsequent multiplication or elimination, etc. Okay, now here is a necessary and sufficient condition for a differential equation of first order and first degree to be exact. Okay, so the necessary and sufficient condition for the differential equation m dx plus n dy equal to 0 to be exact is that del m del y should be equal to del n del x. Okay, that means the if you take the partial differentiation of m with respect to y, that should be equal to the partial differentiation of n with respect to x. Okay, then we say that our differential equation is exact, right? So the proof is not yours. Okay, you need not like know about the proofs. So here because it's an application chapter, so the working rule for solving an exact differential equation is that, so compare the given equation m dx plus n dy equal to 0 and find out m and n, then find out del m del y and del n del x. Okay, so if these two are equal, then only we can say that our given equation is exact. Okay, then if it is exact, then we are integrate m with respect to x, treating y as constant, and integrating step 2 is that integrating the first step is integrate m, the first function, with respect to x, treating y as a constant, and step 2 is that integrate with respect to y, okay, only those terms of n which do not contain x. Remember these things. Okay, first one is we need to integrate m with respect to x considering y as constant, and second this thing is that integrate with respect to y only those terms of s which do not contain x. That means only the y terms we will integrate. Okay, and after that we will take plus n equal to c. Okay, so in short, the solution of exact differential equation m dx plus n dy equal to 0 is integrating m dx treating y as constant plus terms in n not containing x whole into dy equal to c, where c is an arbitrary constant. Okay, so here is a solved example. So this is our mxy dx plus nxy dy. So what is our m? M is this and n is this. Next to calculate del m del y and del n del x. Now we see that these two are equal. That means del m del y is equal to del n del x. So the equation is exact. Now the given equation is exact. Hence its solution is integration of m dx treating y as constant plus terms in n not containing x whole into dy equal to c dash. Okay, That means integration of first function x square minus 4xy minus 2y square whole dx plus terms of n not containing x. So which term? This term containing x, this term containing x, so y square. So we need to integrate of y square dy. Okay, equal to c dash. So what will be our final answer? X cube by 3. Here y is constant, so x square by 2, so 2x square, 2x square y minus 2xy square plus y cube by 3 equal to, we can write c by 3, c dash we can write c by 3 because this is a constant. To adjust the solution we can write it. So this is our final answer, final solution. Okay, so do in the same fashion this problem. I think already you teach us, you learn this kind of problems in your class 12. So again I am discussing all these things so that you get a better clarity on your subject. Okay, so yeah. Okay, so let me solve this problem. Okay, this is not directly in the form of mdx plus ndy, but we can make it like this way. After adjusting the terms we can make it like this way. So this is our m, this is our n. Next you calculate del m del y. Okay, then del n del x, this, and you can see that both of these are same. Okay, now you can now you can solve it. Integration of m dx plus treating y constant plus those term of n which do not contain x. So that is every term is contain x, because first term is y x square plus y square, that is x is contained. Second term is x by x square plus y square, so again x is contained. So you need to only integrate m dx, okay, equal to c. You get your final answer, right? So like this way there is so many numerical problems they had solved for you, and there I have given also a exercise. Okay, so do this exercise. Okay, that will be helpful for you. Okay, so you just make one copy and do all these problems, right? Okay, if you need to clarify anything else, then let me know. Okay, thank you.